Hello, and welcome to Composing Functions. This will be an intermediate algebra take on it, so it's just kind of the overview of what it means to compose. So let's start with a definition. Evaluating one function at another function is the operation called composition. If we're given two functions, f and g, we write f composed with g, and the composed with is a little open circle. It almost looks like the dot like multiplication, but it's an open circle. So maybe fog. F composed with g of x equals f evaluated at g of x. And that's all there is to it, is we're just evaluating. So let's practice that a little bit. If f of x is negative 2x plus 7, and g of x is x squared plus 1, we can find f of 1, right? F of 1. I know that the function f has the basic form of negative 2 times something plus 7. This 1 inside the parentheses on the left side of the equation tells us exactly what to put over here on the right side. So negative 2 times 1 plus 7 becomes negative 2 plus 7, which is 5. Right? You can evaluate a function. You can totally evaluate a function. So g of negative 4. Well, the function for g is something squared plus 1. And I like to get this structure down first. Anywhere there was an x, I open it up with parentheses and then just keep going. G of negative 4, that negative 4 tells us exactly what to put in here. Negative 4 all squared, that's negative 4 times negative 4 is 16 plus 1, which gives us 17. Okay, so we could evaluate no problem at all, here, there, anywhere. So we look at f of a. F is negative 2 times something plus 7. In this case, that something is the a. And to simplify, there's really nothing we can combine, but we could write it without the parentheses, negative 2a plus 7. We can evaluate at a number. We can evaluate using a different variable, or we could evaluate using a word. It doesn't matter. G of hello. G is something squared plus 1. And with the hello inside the parentheses on the left, it tells us exactly what goes inside the parentheses on the right. Yeah, that doesn't make any sense mathematically, but it's a great example of, hey, you could just substitute stuff. All right, so as I'm looking at f of g of x, right? So I can evaluate at a number, at a variable, at a word, why not at another function? So the first thing I'm going to do is I'm going to leave the outside function alone, and that's the f. And I'm going to replace where it says g of x here inside the parentheses. I'm going to write down exactly what g of x is. G of x is x squared plus 1. So f evaluated at g of x is the same as or equal to f evaluated at x squared plus 1. Now we look at the format of f. F is negative 2 times something plus 7. And the line right above it tells us exactly what that something is. It's the g of x, which we actually call x squared plus 1. And then we can simplify. We distribute that negative 2, so it'll be negative 2x squared minus 2 plus 7, which is negative 2x squared plus 5. Notice we're not looking for what is x equal to. We're just looking for a new function. F composed with g of x, or f evaluated at g of x, is an entirely new function on its own. We're not looking to find a specific x. We're just writing a new function. Awesome. All right, let's try with some more functions. Let's do only the composing for a while. So I'm going to use, in f will be black, in g will be blue, and h will be green. So we'll kind of keep those together as we're writing these so we can see where each part came from. So f composed with g of x is f evaluated at, and then g of x, instead of its formal name, let's use 2x plus 6. Now we have only one function remaining, and so we want the form of that, and that's f times something minus 8. That's my skeletal form of the function. 5 times x minus 8, that x is variable, it varies, it's something. 5 times something minus 8, and we know that that something is 2x plus 6. Now, if you get to here, that's awesome. I'm super happy if this is your first time seeing composition of functions, but let's not forget to practice our simplification. We're going to multiply 5 times 2x to get 10x, 5 times 6 to get 30, and then we don't forget about the subtracting 8. Combine like terms, and we have our new function, f of g of x, which equals 10x plus 22. All right, let's try another one. I'm going to scoot this up a little bit. G of f of x. So that's g of what? Well, f of x is 5x minus 8. So I want to put 5x minus 8 anywhere there's a variable in g. Well, what's the form of g? G is 2 times something plus 6. What is that something? What is that value that I'm missing? That's the 5x minus 8. All right, I put f right inside of my g equation in place of the variable. Distribute. 2 times 5x is 10x. 2 times a negative 8 is a minus 16. Don't forget the plus 6 at the end. And I find a new function, 10x minus 10, that is g composed with f of x. Super important right here, notice the f composed with g of x and g composed with f of x, they're not the same. They are not the same function. So we could add two functions in any order, it's no big deal. We could multiply two functions in any order, is no big deal. But if we subtract two functions, if we divide two functions, or if we compose two functions, they're not necessarily going to be the same, so order matters. All right, let's get h in here. So f evaluated at h of x. This is f evaluated at, you see my h of x is pretty long here, that's why I put the big parentheses. 5x squared plus 2x minus 7. All right. The form of f is 5 times something minus 8. And we know exactly what that something is. That something is h. 5x squared plus 2x minus 7. And now we can simplify. We're going to multiply 5 times 5 to get 25. X squared. 5 times 2x is a plus 10x. 5 times a negative 7 is a negative 35. Don't forget the minus 8 on the end. And I'm going to move this one over here. It's actually coming from here. F evaluated at h of x is equal to 25x squared plus 10x minus 43. Right? We have to combine that 35 and the 8. They're both negative. All right. Wouldn't it be nice if I could get this on the same screen? So here we go. So we want h evaluated at f of 1. I can find out exactly what f of 1 is. Remember, f of x is 5x minus 8. I'm going to need to scroll a couple times here. The function f is 5x minus 8. So f of 1, oh, I did it wrong. Let's use this skeleton form. F of blank minus 8. In this case, that's f of 1. F of 1 minus, f of 1 is 5 times 1 minus 8. 5 times 1 is 5. Minus 8 is negative 3. So if I find f of 1 to be equal to negative 3, that's what I could put in this parenthesis, right? On number 3, f of h of x, I replaced h of x with its rule. Here I'm going to replace f of 1 with its value. So now I can look at the function h. It happens to be right here since I've scrolled past it. That is 5 times something squared plus 2 times something minus 7. And we just found that f of 1, the formal name of that, quote, something, is -3. So everywhere I have parentheses, I'm going to put in a -3, and now we can simplify. So we'll have 5 times 9, -3 times -3 is 9, positive 9, minus 6, minus 7, 5 times 9 is 45, minus 6 and a minus 7 is minus 13. This will give us a 32. So if our input is an x, our output will be a function involving x. But if our input is a single number, whether it's a composition or just regular evaluating, if we input a single number, we're going to output a single number for functions. All right, this one's a little shorter than the rest, but we're looking at the basic skills here. That's it for this one. Thanks for listening.